Download this code from codegive.com, link in the description below. A deep dive into d3d11 compatibility for engine fixes, understanding requirements and code considerations. This tutorial will provide a comprehensive understanding of the d3d11, directx compatibility requirements for using engine fixes, specifically focusing on its relevance to modding and tweaking games that rely on this API. We'll cover what d3d11 is, why it's important, how to check your GPU's compatibility, and offer code considerations for modders aiming to interact with d3d11 in a robust and compatible way. We'll also briefly touch upon potential pitfalls and troubleshooting. What is directx 3d11, d3d11? D3d, is a part of Microsoft's directx API, Application Programming Interface. directx provides low-level access to hardware resources, particularly the GPU, enabling developers to create visually rich and performant applications like games. d3d11 is a specific version of directx, introducing significant advancements over its predecessors. Key features of d3d11 shader model 5.0 d3d11 uses shader model 5.0, which allows for more complex and flexible shaders, enabling more advanced visual effects. Shaders are programs that run on the GPU, responsible for calculations related to vertex positions, lighting, texturing, and more. Compute shaders introduces compute shaders, allowing the GPU to be used for general-purpose computation, beyond traditional graphics rendering. This is useful for physics simulations, AI processing, and other performance-intensive tasks. Tessellation provides hardware tessellation capabilities, allowing the GPU to dynamically subdivide and refine surfaces, creating more detailed and realistic models. Multithreading offers improved multithreading support, allowing the CPU to more efficiently manage rendering tasks and reduce bottlenecks. Deferred contexts enables the creation of deferred contexts, which allow rendering commands to be recorded and executed later, further improving multithreading performance. Improved resource management introduces more sophisticated resource management features, allowing developers to optimize memory usage and improve performance. 2. Why d3d11 compatibility is critical for engine fixes. Engine fixes are modifications or patches designed to address bugs, performance issues, or other limitations in the underlying game engine. When an engine fix relies on d3d11, it expects the GPU and its drivers to fully support the d3d11 API specification. Here's why this is essential. Core functionality dependence. The engine fix might directly hook or modify d3d11 API calls, intercepting and altering how the game interacts with the GPU. If the GPU doesn't fully support d3d11, these hooks can lead to crashes, rendering errors, or unexpected behavior. Shader manipulation. Many engine fixes involve modifying or injecting shaders to improve graphics quality, fix lighting problems, or implement new visual features. If the GPU's d3d11 support is incomplete, these shader modifications could fail to compile or execute correctly, resulting in visual artifacts or instability. Performance optimizations. Some engine fixes aim to improve performance by leveraging d3d11 features like multi-threading, deferred contexts, or optimized resource management. These optimizations rely on the GPU's ability to correctly execute these d3d11 commands. If the GPU has limitations, the optimizations could backfire and worsen performance. Asterisk driver compatibility. Asterisk d3d11 functionality relies heavily on GPU drivers. Even if a GPU is technically d3d11 compatible, outdated or buggy drivers can still cause problems. Engine fixes often assume that drivers are up to date and functioning correctly. In short, without a fully d3d11 compatible GPU and up-to-date drivers, engine fixes that leverage d3d11 are highly likely to break the game or introduce severe graphical issues. 3. How to check your GPU's d3d11 compatibility. 1. Check GPU specifications. The easiest way is to consult your GPU's specifications. Search for your GPU model online, example NVIDIA GeForce RTX 3080 specifications. Look for the directx support section. It should explicitly state directx 11 or directx 11.x or higher. Modern GPUs generally support much more recent versions of directx, 12, 12.1, 12 Ultimate. 2. Using directx diagnostic tool, DX diagram. Asterisk press the Windows key plus R to open the Run dialog. Asterisk type xdiag and press Enter. Asterisk the directx diagnostic tool will open. Asterisk under the Display tab, look for the Feature Levels section. This shows the feature levels that your GPU and driver support. If d3d11 functionality is supported, you should see 11_0, 11_1, or higher listed. 3. In-game settings. If available, some games display directx version information in their settings menus. While this doesn't guarantee full d3d11 support, it can give you a clue. 4. Code considerations for modders and engine fix developers. When developing engine fixes that interact with d3d11, consider the following. Asterisk explicit feature level checks. Asterisk before attempting to use specific d3d11 features, explicitly check if the GPU supports them. This avoids crashing the game or triggering undefined behavior. Asterisk robust error handling. Asterisk always include comprehensive error handling for d3d11 API calls. This helps you identify and gracefully handle situations where the GPU or driver is not behaving as expected. Asterisk driver version detection. Asterisk consider implementing driver version detection to identify potentially problematic driver versions and provide warnings to the user. Asterisk fallback mechanisms. Asterisk if a specific d3d11 feature is not supported, provide a fallback mechanism that uses alternative techniques or disables the feature altogether. This ensures that the game can still run, even if some functionality is limited. Asterisk careful resource management. Asterisk d3d11 resource management is crucial. Avoid memory leaks and other resource-related issues, as they can lead to crashes and performance problems. Asterisk shader compilation errors. Asterisk pay close attention to shader compilation errors. Use the d3d compiler API to compile shaders and check for errors. Provide meaningful error messages to the user to help them diagnose the problem. Asterisk debugging with Pix. Asterisk Microsoft Pix is a powerful debugging tool specifically designed for directx applications. Use Pix to capture and analyze d3d11 frames, identify performance bottlenecks, and debug rendering issues. V-code examples, illustrative. This section provides simplified code snippets to demonstrate some key concepts. These examples are for illustrative purposes and may require further refinement for real-world use. This section relies on C++, commonly used for game modding. 1. Checking d3d feature level asterisk. Explanation asterisk includes the necessary d3d11 header file. d3d feature level defines an array of feature levels to check for. We start with the highest, 11_1, and work our way down. *d3d11 create device attempts to create a d3d11 device. The supported feature level parameter will be set to the highest feature level that the GPU and driver support. Error handling checks if the device creation failed. Feature level check compares the supported feature level to d3d_feature_level_11_0 to determine if d3d11 is supported. 2. Simple shader loading and compilation with error handling ***. Explanation ***. Includes d3d compiler.h for shader compilation. You need to link against d3d compiler.lib, usually present in the Windows SDK. d3d compile from file compiles the shader from a file using the d3d compiler API. Error handling the crucial part. Checks if d3d compile from file failed. If it failed, it checks if an error blob was created. If so, it retrieves the error message from the blob and prints it to the console. Create vertex shader creates the vertex shader object from the compiled shader bytecode. Resource release releases the shader blob after the shader is created. This is critical to prevent memory leaks. Shader model the VS_5_0 parameter specifies the shader model. This must be compatible with the GPU's supported feature level. 3. Checking for feature support, example compute shaders. Explanation check feature support this function is used to query the device for specific feature support. d3d11 feature data d3d11 options this structure contains information about various d3d11 features. Compute shaders plus raw and structured buffers via shader for x this member of the options structure indicates whether compute shaders are supported. Note, more modern feature detection mechanisms exist for d3d11.1+. Important always check for feature support before attempting to use a feature. 6. Potential pitfalls and troubleshooting. Outdated drivers ensure that you have the latest drivers for your GPU. Outdated drivers are a common cause of d3d11 compatibility issues. Download them directly from NVIDIA, AMD, or Intel's websites. Driver bugs even with the latest drivers, there can still be driver bugs. If you encounter unusual crashes or rendering problems, try rolling back to a previous driver version. Mixed hardware if you have multiple GPUs, example a dedicated GPU and an integrated GPU, make sure the game is using the correct GPU. You can usually configure this in the GPU driver control panel. Shader model mismatch make sure the shader model used in your shaders is compatible with the GPU's supported feature level. Feature level errors pay close attention to the d3d feature level reported by DX diagram and your code. If it's lower than expected, it could indicate a problem with your GPU, drivers, or directx installation. d3d compiler DLL ensure the d3d compiler DLL, example d3d compiler _47.dll, is present in the games directory or the system32 directory. This DLL is required for shader compilation. It is part of the directx SDK. Administrator privileges some d3d11 operations may require administrator privileges. Try running the game as an administrator. directx installation if you're still having problems, try reinstalling directx. the web installer is usually sufficient. Overclocking excessive overclocking can sometimes lead to GPU instability and d3d11 errors. Try disabling or reducing your overclock. Hardware failure in rare cases, d3d11 compatibility issues could indicate a hardware failure. If you suspect this, consider running a GPU stress test. 7. Beyond the basics, advanced considerations. D3d11.1 and higher while D3d11.0 provides a solid foundation, newer D3d11 versions, 11.1, 11.2, etc., introduce further improvements and features. Explore these versions if the target game supports them. Command list / bundles D3d11 supports command lists, also known as bundles. These pre-recorded command sequences can be executed multiple times, reducing CPU overhead and improving performance. Resource views understand the different types of resource views, render target views, depth stencil views, shader resource views, unordered access views, and how they are used to access resources. Threading considerations when working with D3d11 in a multi-threaded environment, pay close attention to thread safety and synchronization. 8. Conclusion. D3d11 compatibility is essential for running and modifying games that rely on this API. By understanding the requirements, checking your GPU's compatibility, implementing robust error handling, and using appropriate techniques, you can create engine fixes that improve the game's stability, performance, and visual quality. Remember to prioritize error handling and compatibility checks in your code to ensure a positive user experience. This detailed guide is a starting point, and further research and experimentation are encouraged for advanced techniques and specific game engine integrations. Good luck.